Uh, Hello?
Hello, can you hear me?
Yeah, yeah, yeah.
Okay, okay, thank you for joining. Okay, so we will start our today's class. So basically, you already enroll our online training program on future land use, land cover prediction. Okay, as well as how we can easily make the land use, land cover classification using Google Earth Engine. And after that, how we can easily predict the land use, land cover classification. Okay, so basically, I will try to explain all of method not only for the Google Earth Engine, as well as I also try to explain about that other model, other land use, land cover change modeler, how we can easily use, and further we also try to predict land use, land cover. Okay, so let's go.
Yeah.
We start one by one. So let me share my screen.
Okay.
Okay, can you see my screen? Is it visible?
Yeah.
Okay. Okay. So basically, we try to discuss this online training program on mastering land use, land cover prediction mapping using machine learning, not only for the machine learning, as well as we also try to discuss about that other modeler. Okay, so different types of land use, land cover modeler we are also use, and further we can also make the prediction. So I will try to explain all of those things. So basically, this is the total 7 days online training program, and each day mainly I try to cover the 2 hours. Okay, these are 2 hours each day I will provide.
Mhm.
Okay, and for we try to cover all of topic. So basically you can say I already added a lot of topic. Okay, so let's go try to start one by one. Okay, if you have no knowledge about the Google Earth Engine, or if you have no knowledge about the different types of modeler, don't worry about that. I will try to explain all of those things from beginners to advanced level, and I hope after completing that you can easily work with the different types of land use, land cover classification project, and also for prediction work. So let's go try to start. Okay. So first of all, we need to select our study area. Okay. And I hope you already make the account on Google Earth Engine. Did you do it or not for registration?
Yeah.
Okay,
Yeah,
great.
yeah, yeah. Yeah, I already make it and I already start to classify.
Okay, so it's already done. And you also get this type of code editor. Yeah. So this is the Google Earth Engine code
Yeah.
edit. Okay, so done. You already completed the registration. First of all, I will try to explain about the method. Okay, so different types of method we are applying for land use, land cover classification, and also prediction. Okay, there are a lot of method. If you want, you can simply go to the, suppose I simply show you some paper. Suppose I simply go to the Google Scholar and show you some paper. Then you also get the idea how it will be work. Okay, so different paper they're also using the different way for prediction. So I simply search here, suppose land use and
Yeah, most of them they are use CV Markov
yeah,
and
yeah, yeah,
prediction.
classification.
Can you answer me why most of them they are going in this method?
Okay, I try to
I
explain all of
mean, we
method,
can
no
use
problem.
machine learning, we can
Yes,
use
yes,
deep learning. Why they are
yes,
choosing?
yes. The maximum paper, if you want, you can use at the CA or cellular automation. Okay, and ANN simulated they are using here, so it's one kind of paper. So assessment of the land use, land cover change, and future prediction, they are used at the CANN simulation. Okay, so basically for using this simulation we can easily use the different types of tool. It can be QGIS Molusce plugin we can also use, as well as if you want, you can also use here the IDRISI, Selva, it also use, or if you want, you can also use here the Terrset. Okay, Terrset we can also apply this type of land change modeler. We can also apply, and then further we can also make the prediction. Okay, so in this case, I will try to explain this type of tool, as well as I also try to show you that how we can easily use the machine learning and then make the prediction. Okay, then we can easily compare the result. So which result we find out the more better accuracy, or which one find out the more good accuracy. Okay, so this type of things I also try to explore one by one. Okay, so first of all, we need the study area. Suppose which area you want to work. So in this case, I will try to use my own area. And after completing the class, I will provide you the recorded class as well as also practice code. Okay. So you try to implement this type of work for your own study area. Okay. And further, if you face any problem or you need any confusion, then you can also ask me the next class. Okay, so every class I try to use my own study area, and I will give you all of code, all of recorded class, you can easily get it. And further, you also try to implement using your own study area. Okay, you can easily make the map or other things you can do for your own study area, and then you can also learn. And further, face any problem, then I also guide you. Okay, so let's go. So first of all, you need to download your shapefile. Okay, which area you want to work. So it can be different types of city, different types of region or geometry. So we can easily get the shapefile from here. This is the link. Okay, so this is the link gadm.org. So from this website, we can easily access all of country level shapefile, district level shapefile, sub-district level shapefile, or any shapefile for all of world. We can easily get it from here. So you can simply click on the data. So now we can get all of data. You can see you can download the special data by country. And from here, you can easily choose your own country. And further, you can easily download the shapefile, mainly administrative level area. We can easily get it from here. So you can simply choose your own country. So I want to work for, suppose I need the Bangladesh country. So just I simply click on Bangladesh. And further, I download the shapefile. You can see the shapefile. I need the shapefile. Okay, just click on the shapefile. So now it downloaded this shapefile.
Is all the
Yeah. So all level.
I mean, is it all the country implemented in this website?
Yeah, here we find out that all of country in the world. Okay, any kinds of country. So you can simply choose your country name, and further from here you can easily download your shapefile for your all country administrative level area, country boundary, division, then district, sub-district, or union. So all of level boundary area we can easily access from here. Okay, so you can see that the all of country level is available in here. So I simply download it from here. And further, if you have, you can also work with, suppose I want to open my ArcMap software. Just simply open. And now I want to open this shapefile in my ArcMap. Further, I choose my study area and then import this study area in Google Earth Engine for land use, land cover, classification, or prediction. Okay, so just I simply open it, ArcGIS. Do you have this ArcGIS software or not?
Yeah.
Okay,
Yeah,
great.
I have it. The version.
Okay, great. Okay, no problem. It's okay, no problem. From this shapefile and further upload in Google Earth Engine. Okay, so it's opening. So here I already downloaded my previous time this shapefile. I simply import it. So from the download folder. This file I already downloaded. Just I simply open.
Okay.
So here we find out the all of level, but I want to work for that level 4. Suppose my study area in level 4. So just I simply open the level 4 SSP, this shapefile open in here. So now all of boundary, mainly level 4, all of boundary, it appears in my ArcMap software. Okay. So from here, I just choose only for my specific boundary, which area I want to make the land use land cover, and which area I want to make for the prediction. So you can simply choose your study area. Suppose I simply filter. I just simply click on here. You can see the selection, select by attributes, and further I choose the column name 4, double click, and then equal get unique values. I simply search. So now all of area including in here. From here I just choose only for, suppose I need the specific, suppose for, let me find. Oh, sorry, it will name. Okay, let me try for name 3. Get all unique values, and I simply search here. So I need this area, Rangpur Shadow, and then further I just put the equal sign in here, and then apply
Okay.
and OK. So now it select my study area. Okay, suppose this study I want to need, and further I want to make the land use land cover prediction map. So for doing this thing, just click on here, and then just export data, and then I simply put the name. So I save it in the, just I try to make a, okay, I try to make a new folder in my data. I just try to make the new folder. In the data folder I put this name, suppose LULC prediction. So in this folder I want to keep all of data, shapefile, everything I want to put in here. So just I put it, and I put the file name. Suppose I put the file name is that, I put this time, and then save, and further okay. So now I want to add the layer of my study area. Okay, so now I got, this is my study area. Okay, but in this time I want to work for this full study area. Okay, I want to work for this full study area. So this type of boundary I not need. Okay, in the middle portion I don't need. Okay, I just need only for this boundary. So for that I simply use
Yeah.
the dissolve tool, click on the
Yes. Yeah.
geoprocessing, and further click on the dissolve, and I want to input feature, simply put here this wrongful, this new file, simply input the wrongful file. Then I just get only for this boundary. Okay, Rangpur Shadow's boundary, but all of things I don't need. And further dissolve field, I choose the dissolve field for name 4. Okay, then okay. So now it's dissolving. Okay, I think so. Okay, so it will be level 4. Okay, geoprocessing, then dissolve, input feature, these things, and I have to choose here dissolve name 4. Okay, because I want to remove the name 4, mainly this type of boundary I want to remove. So now geoprocessing, dissolve. Okay, so now it removed. Okay, so now we are just get only for this boundary. Okay, so for this boundary I want to
Okay.
work, and then work with that. So let's go, we try to do it. So for doing these things, just I export again this file. So export data, and I put this, I put here, let's say RY. Okay, or I put here study area. Okay, then save it, and then okay. So now it's saved. Okay, so our shape file is ready. So this is my study area. I want to work for this land use land cover, and further we try to make the prediction. Okay, so now this study area we need to import in our Google Earth engine. So let's go try to import. So for that, simply open the code editor. So now simply import your study area. So click on the new, and then click on the shape file, go to the source file, and I want to keep it in my data folder, LULC prediction folder. I want to keep study area. So just SSX, PRJ, DBF, and SSX. Okay. Then simply open, and then okay. So now it uploading. So it takes some time. Okay. So further we can easily, it will be uploaded, and further we also try to work with that. So after uploading this file, we need to work with satellite imagery. Okay. So basically, we can easily access all of satellite imagery from Google Earth Engine, because Google Earth Engine is a totally cloud-based platform. Okay. In cloud-based platform, we can easily access all kinds of satellite imagery. Landsat, Sentinel, Molusce. So in this time, we have to work for the Landsat imagery. Okay. So we have to work for the Landsat imagery. So just click on the browse data catalog. And from this browse data catalog, you can click on the Landsat. Click on the Landsat.
Can we use Landsat 7 or 8 or 9 with collection 2 and level 2 tier
Yeah.
1
Yeah, it also
means the
possible.
high quality imagery.
Yeah, it also possible. So for that, first of all, we have to know about that. What is the time period you want to work, and then you want to prediction. Suppose what's the time interval, 10 years or 5 years, or when you start. Okay, suppose you check some paper, suppose this is the one kind of paper. So in this time, if you want to check their work, so basically they are take this year 2000, then 2010 and 2020. Okay, they are used for the collecting their satellite imagery for 2000, 2010 and 2020. And further they are also predict for 2030 and 40. Okay, for prediction.
Yeah.
So now this type of year, if need, you can say in this they are used the same model to predict the future land use land cover map for year of 2013 and 2040. Okay, and in this time they are also input some, you can see here, they are the landscape satellite image, their acquisition for 2000, 2010 and 2020. Okay, and in study area instructions they are apply the support vector machine, supervised classification land use map they created 2000, 2010 and 2020. Okay, then accuracy assessment they also do, and okay, and training analysis between 2000 and 2020, 2020 scenario prediction, and further validation assessment different kappa. Okay, they are also using here, and they are also use some driving factors. So this type of driving factor you also need when you apply the cellular automata, mainly CA model. And then finally we try to apply the prediction 2030 to 2040. So now for this type of time period we also need to create. Okay, suppose we need to create for 2000, or if you want you can also work for suppose 1990, suppose 1990. Okay, 1990, suppose then 2000, then
Oh.
2010 or 2020. Okay, further you can predict 2030 and also predict 2040. Okay, so if you want you can also follow this time period 1990, 2000, 2010, 2020, 2030 and 40. Okay, So now, if you want, you can also do it, or if you want, you can also change the time period. It's not mandatory. So I will teach you, so you can easily change it for your own year also. So for that, first of all, we have to learn
Okay.
about that, how we can easily create the annual image collection. So basically, it is the annual 1990, 2000, 2010, 2020, 2030, or 2040. Okay, so basically from all of for these 4 years, we can easily get this satellite imagery from Landsat. Okay, so this 2030 and 40, it's our prediction part. It's not covered. So we just try to create the annual image composite. How we can easily make the annual image composite, and further we will discuss about that. Okay, so basically for the prediction or make the historical land use land cover classification, first step is that we need to historical imagery. So in this case, we try to put here 1990, 2000, 2010, and 2020. Okay. So I already imported my study area. So this is my study area. So it's successfully imported. Study area name, I put the file name. So just simply refresh button. So now this file we can easily find out in here. So study area. So this one, I simply import. Okay. So it's imported in my study area. So further, I can simply put the change the variable name, suppose AOI. Okay, do you have the coding ID or not?
The recording.
Yeah, so code idea for JavaScript, do you know or not?
Yeah. I know some
Okay,
coding
okay,
in
okay. Then it
Python,
is
JavaScript. I
okay.
know some
Then you
knowledge
can
about
easily
this.
catch it, no problem. Okay. So now I want to try to add this layer of my study area. So just use here map rotate layer and put here the AOI, and also focus the center of this shape file. So for that, use a map.center object AOI and put the zoom level suppose 10 and click run. So now I can easily add my layer of my study area. So this is my study area. So now for this study area, I want to make the land use land cover classification map for 1990, 2000, 2010, and 2020. And further, I want to make the prediction for 2030 and 2040. Okay, using the machine learning or using the CA model or using the Molusce QGIS Molusce plugin or Terrset or IDRISI Selva. So this type of things I try to show you how we can work step by step. But before that, first of all, we need the data. Okay, we need the land use land cover data for different year. So now we try to discuss about that how we can easily get the imagery for 1990, 2000, 2010, and 2020 for this study area. Okay. Further, we for the other class we'll try to discuss about that how we can easily make the classification using the machine learning. So let's go. So in this time we have to create the annual composite. So for the annual composite, we need the annual image collection. Okay. So for that, first of all, we try to make some.
Sorry, can I ask you?
Yeah, please, please, please.
Um, for the all the years which you are want to classify, you will do the classification in one script or in separate scripts. Means you will do the classification of 1990 and classification of 2000 in other script, or all of them in one script.
Okay, so we can also read all of those things one script easily, no problem. Suppose in the one script, we can take all of imagery, okay, and also make the classification. So basically, from here, we are just generate the data. So this type of data, further we try to use the other software. Or okay, when I want to use the CA model or also use the CANN model, then we have to this type of land use land cover data. We need to import in the other software. Okay, or when I want to show the machine learning for prediction, we also use the Google Earth engine. But when you want to apply the model, different types of model, then we have to use the QGIS Molusce plugin or Terrset or IDRISI Selva. So this type of things we have to use. But we are use the same data. So which data we generate in here, this same data we also use and make the prediction for 30 and 40. Okay. So let's go. We start. So first of all, we have to define our observation year. Suppose I take a variable. I put the variable name. Suppose start year. Start year, suppose 1990, and take the another variable, suppose in the year equal 2000, suppose 2020, or if you want to put the 2030 also, there is no problem. So then we can get all of year, it will be start from the 90 and 2023, all of annual image I want to generate, okay, for this study area. So let's go try to generate. So I simply put my start date and end date, start date and end year, and now I want to make the sequence. Okay, so just make a sequence mainly 90, 1990, 1901, then 2, 3, 4, up to 2023. So all of sequence I want to create. Just take a variable, suppose years, and equal e dot list dot sequence, and I put here the sequence. It will be a start from a start year. I put here the start year, and also end, it will be end year. Okay, and it's not need for the step and count, not need. So just I make the sequence mainly, it will be show all of year from 1992 to 2023. Suppose every single year I want to create the annual image composite for my study area. So it total show that 34 years. Okay, 34 years mainly, it will be start from 1990 and up to 2023. So all of year. Suppose I need all of year annual image collection. But I not use all of year image collection. I just use the 4 images for 4 year. 1990, 2000, 2010, and 2020. I just use this 4 years image and further make the land use land cover classification, and then use this 4 land use land cover image and also make the prediction. Okay, for CANN or other types of model, we try to use and then make the prediction. So let's go. And now we also need the band. Okay. So let's go try to use the band. So just I take a variable. Suppose I take the band for Landsat 5 band, I also need. So Landsat 5 bands equal. And in this case, I want to use this image collection. So you can also check the image. I want to use, suppose, Landsat 8, I want to use Landsat 5 and Landsat 7. Okay. So I want to use the 3 image collection, Landsat 5, Landsat 7, and Landsat 8. Okay. So just click on the Landsat 5. First of all, I take the band, and I want to use from here surface reflectance. Okay, so basically surface reflectance imagery we have to use for make the land use land cover classification map. And if you check the band name, so here you can see this band name is the SRB1, SRB2, SRB3. So just I put here this type of band name in here. Just make a list, and in the list I want to add all of bands. So just put here SRB1, then put here SRB2, then put here SRB3, then put here SRB4. Okay, and then
You are going to the satellite imagery.
yes, we take the after first of all we try to set all of band, then we select our satellite imagery. Okay, so first of all we try to add all of band from the Landsat 5, 7, and 8. So Landsat 5, then Landsat, then we put here the SRB6. Okay, and B6 is not available. I think it will be have the B7. Okay, B6 is not available for the Landsat 5. We have to just put here the SRB7. Okay, and further we also take the another variable and put the L5. We are also put all of name. Okay, put here the names and make the list. So basically SRB1, it's a blue band. So I put here the it's a blue. Okay, then SRB2, basically it's a green band. And then put here that SRB3, it's a red band for Landsat 5, yeah. And then put here the near infrared, it's a near. Then put here that short wave infrared 1, and put here the short wave infrared 2 band. Okay, and basically 1, 2, 3, 4, 5, 6. Okay, and also in head 6. Okay, so we put here the 6 band name. Okay, blue, green, red, near infrared, short infrared, and short infrared 2. So this band we just simply import for Landsat 5. So now take the another one for Landsat 7. So just take the variable, suppose L7 bands equal. So we'll just put same way all of band for Landsat 7. So just put here SR B1, then put here SR B2, SR B3, then SR B4, SR B5, same as SR B7, because 6 band is not available also for Landsat 7. And further just use the same information we also need. So I just copy and paste. Okay, it also save our time.
Yeah.
Simply copy and paste. Change the variable name, it's an L7 name. So we just put here that blue, green, blue, green, then red, then near infrared, then short wave infrared, short wave 2. Okay, it's done. And finally, Landsat 7.
What is different? Oh, what is difference between Landsat 5 and Landsat 7?
So this different basically time duration. Time duration. Suppose you can check the
Okay.
Landsat 5 is available from year of 1984 to 2012. Okay. Landsat 7 is
Yeah.
also available for the other time. Landsat 8 is also other time. Okay. So it's a depend on the time duration for this. And I take the another one. Finally, Landsat 8 band, L8 bands. Okay, and in this time it will be start from just make the list. In this time, for the blue band in Landsat 8, it will be SRB2. Okay, so for the Landsat 8, blue band name is SRB2. Okay, further we have to put here that SRB3, SRB3, then put here SRB4, then SRB5, and SRB6. Okay, in this time B6 is available, and further we also put here that SRB7. Okay, and then put this name. Just take a variable var L8 name, and name is the same. Okay, name is the same. Just simply go with the same name I put in here, because in this time we are just use the same name. SRB2 is the blue band for Landsat 8, SRB3 is the green band, SRB4 is the red band, SRB5 is the near infrared band, SRB6 is the short wave infrared band, SRB6 is the short wave 2 band. Okay.
What about the band 1 in Landsat 8?
Landsat band 1, it's also added the new information. It's called the coastal aerosol. Okay, Landsat 8 band 1, Landsat band 1, it's called the, if you check it, suppose I just simply open. Okay, but for the Landsat 5 and 7, it's called the blue band for band 1. But Landsat 8 B1 is not the blue band, it's just coastal aerosol.
It's ultra blue.
Yeah. So that's why we are select the SRB2. Okay, we start from the SRB2. Okay, but it also provide the SRB6 also. Okay, but Landsat 5 and Landsat 7 are not provide the SRB6. Okay, but Landsat 8 is provide the SRB6 band also. So this is the basic difference between the Landsat 5, 7, and 8. So that's why in this time here you can see for the name is the same. Name is the same. All of satellite which I put the band name is the same. Okay, but difference only for the band number. So the SRB2, SRB3. Okay, so now when I make the composite, so I can simply use here the blue, green, red, near infrared, short wave infrared, and short wave 2 for any year I can use. So just we simply select our band. After that, we filter our image collection. So let's go try to filter. So first of all, I just take a variable. I put the variable name, suppose L8 equal and I call my satellite image collection. So this is the satellite image for the Landsat 8. So just copy the Earth engine snippet. So this is the Earth engine snippet. Copy, copy, and paste here.
Can I ask you, just wait. Here, you do classification, and before that, you just try to respect that all the Landsat image should be have the same bands. Means
Yes,
all
yes,
are
yes.
blue, green, red, have the same bands. Can I, for example, for Landsat 8, include the band 1, for example, and Landsat 5, keep it with the different
So in this case, we try to create the annual image
classifications?
collection. Okay. So in this annual image collection, we consider the similar band. Okay. Blue, green, red, near infrared, short wave infrared 1 and short wave infrared 2. Okay. This 6 band we consider as a similar band. Okay. For any time duration. And blue, green, red, near infrared, short wave infrared, and short wave infrared 2. These 6 bands are available Landsat 5, 7, and 8. 3 satellite imagery, you can get the
Yeah.
information Landsat 5, 7, 8. And further, we also make them combine Landsat 8, Landsat 7, Landsat 5. We are just simply combine and make sure just keep the same band name and same band. So further, when you just simply merge, then we can just blue, green, red, near infrared. We can easily work with that. Okay. So I will show you that one by one. Just a minute. So now we are just take the image collection, Landsat 8, and further I simply filter. So just put here the filter date function, filter date. Suppose I put this time period, suppose I put the year of 2012, suppose 04, suppose 01, from year of 2000, suppose 23, December 31. I put this type of time period. And then put here the filter metadata and put here suppose cloud cover less than, I choose suppose less than 1, and then put here the dot filter bounds, filter boundary with my AOI. Okay, and then put here the select function, just call the select, and then I call the Landsat 8 bands, copy and paste here, and put here the Landsat 8 names. Okay, now we can easily replace it with the names. So now this is my one kind of
Is it
collection.
okay that
Yeah, please.
is it okay that we can use the for the filter date we can use the whole year? I mean, not only 2 or 3 months.
Yeah, so we create the annual image collection. Okay, so basically Landsat 8 is available from 2013 0308. So if you want, you can also start from
No,
2013.
no. For example, we can use from January till December.
Yeah, yeah. 24, 10, 12. Just I put here 24. So we find out the total 40 images. Okay, so it's not our ultimate goal. Okay, so our goal is that we create the annual image composite. Okay, we have just merged Landsat 5, 7, and 8. We have just merged Landsat 5, 7, and 8 and create the total 34 image years. Okay, from 1980 to 2023. So just we create this type of things. After that, we also call the Landsat 7. So just I simply copy the same code. I just simply copy the same things and paste here. And now I call the Landsat 7. Simply call the Landsat 7 because we take the Landsat 8. Further, we take the Landsat 7. Just click on the Landsat 7 and then surface reflectance. Just copy, simply copy, and I change it. Just paste here. Okay. And for the Landsat 7, I just keep this time, which is available from this. And last time is that 2024-01-19. Just change the time period. And I'll change the band name. So L8, L7 bands and L7 names. So now I also put the change the L7. Okay, so now if I check how much image is available for that, so click to the run. So now we find out the 52 images. Okay, so same as for Landsat 5, just simply copy and paste here. I change the variable name L5 and also put here the L5 bands and also put here the L5 names, and then find out the Landsat 5 image collection from here. So in this code, I try to show you that how we can easily combine. Okay, and then we create the annual image composite. Okay, so all of we just combine Landsat 5, 7, and 8, both of all of imagery for my study area, and then we are just make the annual. Suppose 1990, 1982, 1983, and up to 2023. So then we can easily find out all of annual image collection. Just simply copy and copy this Landsat 5 image collection and then just simply change it. Okay, and you're going to check the time period. It will be able from 1984 036 from just I simply copy and paste here. Just paste and further 2012 0505 simply copy and paste here. Okay, so now total 5. If I check how much image for that, so just I simply L5 dot size. So now it computing how much image we find out for Landsat 5 for my study area. So you can see here for the 42, we find out the Landsat 8, 52 Landsat 7, 48 for Landsat 5. So now we combine total 42, 52, and 48. Further, we make the annual only for the separate year. Only for the 90, 91, 92, 93, 94, 2000, 2010, all of year. Okay. Total 34 years image we try to generate from here. So let's go. We try to merge all of images one by one. So for merging, just take a variable. Suppose I put the variable name is that full. I put the full collection, and I call the L8 dot merge with L7. It also merge with L5. Mainly Landsat 8, Landsat 7, and Landsat 5 simply merge together. And after doing these things, if I check from here, suppose just print the total collection. So here you can see I simply copy and check it. Just use here the size function. So now it computing the total collection after merge. Landsat 5, 7, and 8. We find out 142. Now this 142 image, we just make the annual 34th annual image composite we create. So we find out total 142 images for my study area. So now this 142 images from here, I just take only for the 1 year. Suppose 1998, just only for the 1998, 92, 93, all of total 34 years image we create from 142 image collection. So now we try to make the annual image composite. So for creating the annual image composite, just take a variable. Suppose annual collection we try to create. So annual collection. So in this annual collection, I just use a function, this function called the ee dot image dot image collection dot from images. Okay, so in this case I have a image 142. Okay, this
Yeah.
142 image I want to convert into annual total 34 years annual composite I want to create using 142 images. So I have an image collection. So this image collection I want to convert total 34 years annual image composite. So for that I have to use ee.image collection from image, this function. Okay, after use this function, we have to create a function. Basically, we have to create the annual function. Just we put in here. So for doing these things, just we create a function. Okay, just in this time, create a function. So in this function, I take the one element, suppose y, and further in this curly bracket, I define what is my argument. So my argument is that I want to use 142 images and create the yearly median composite. Yearly median composite I want to create. So this is my argument. So for that I take a variable, suppose annual equal, I just take a variable annual, and further I call my collection 142 image collection. It is stored in this variable full collection. Simply copy and paste here. Okay, and then these things I want to filter annually. So in this case, this 142 is available Lancet 5, 7, and 8. But I want to filter it annually. Suppose only for the 1 year. Only for the 1 year, how much images available? Suppose 990,
Yeah.
how much image? 902, how much image? So I want to filter according to the calendar range. So for that user ee dot filter dot calendar calendar range. Calendar range. So in this calendar range, I simply put here the y yearly and unit is the year. Okay, because I want to filter from 142 images. I just finally find out how much image is available only for the year. Suppose 900, how much image? 902, how much image? 903, how much image? 904, how much image? Okay, so after getting this information, all of images, all of yearly images, I create the median composite. Okay, suppose I find out in 1991, I find out the total 5 images. So this 5 images, I take the middle pixel value and create the median composite. So just use the median function. So median. Okay, and these things clip with your study area, which is AOI. So this is the function. So in this function, what I do, just I have total 142 images. This 142 image I want to convert into total 34 years composite. So first of all, I try to filter 142 images yearly, and then each year I create the median composite. So this is my function. So now this function which I write, this function I want to connect with my year. Basically, which year I want to apply in here. So these things I want to apply with my year. Then we can easily get this result. So let's go. I will show you that how we can easily generate the year. So I already make the